Hello everyone, good morning. So I hope you all are good and everything is going good. So today what we are going to do is, already I have informed you yesterday. Today I will be solving some questions from some means some three or four questions from electric field and potential concept, and then we will be moving ahead with that is your capacitor thing. Okay, so should we get started? It is 10:01. I'm just waiting for some more 30 seconds. If anyone is left to join, then I'm just waiting for that for them. चलो ठीक है. So let's move on to the question. Here on the screen, you can see the very first question. So just like yesterday, what do you have to do? You have to read the question very carefully. So read the question carefully and take some 3 minutes of your time. 3 minutes will serve the purpose. First, read the question. If it is taking 1 minute, it's enough. It's good. Nothing to worry about. Read the question carefully and after that, try solving. Do it now. If you have any doubt, you can text me. You can let me know. Okay, so I hope you all have studied, read the question carefully, and you all must have tried doing it as well. So now let's do it together. So what the question is, there is a disk of radius a by 4. So there is a disk of radius a by 4 having a uniformly distributed charge 6 coulomb. And this is placed in the XY plane with its center at minus a by 2, 0, 0. 0. Done. So this is our disk here, and its center is at which coordinate? That is minus a by 2, 0, 0. A rod of length L of length A carrying a uniformly distributed charge 8 coulomb. So this is the rod, and its length is how much? Its length is A, and it is carrying charge 8 coulomb. Again, that is uniformly distributed. Okay? And it's placed on the x-axis from x equal to a by 4 to 5a by 4. Means this is x equal to what? A by 4. And this is up to x equal to 5a by 4. Definitely y and z coordinates are 0 because it is lying along the x-axis, right? 2-point charges minus 7 coulomb and 3 coulomb. Minus 7 coulomb is kept here. Minus 7 coulomb is kept here. A by 4 minus A by 4, 0. X is positive, Y is negative. So definitely this is our fourth quadrant. And another charge, 3 coulomb, it's kept here. And its coordinate point is what? Minus 3A by 4. X is negative, Y is positive, and Z is negative. Then consider a cubical surface formed by 6 surfaces. Now we are given a closed surface and its x, y, z is given like this: plus minus a by 2, plus minus a by 2, plus minus a by 2. So this is a cube of side A by 2 kept in XYZ plane. Done. So if we see, if we draw the cube, so it will look something like this, right? Something like this. My diagram is again very much poor. So it will look something like this. Let me make it move beautifully that I can. Okay. So what it will look like? So I have drawn the cube here. Done. So its side is how much? A by 2. So you can see clearly which portion of charges or how many charges will be inside this cubical surface. Electric flux nikalna hai. Done. So if we apply Gauss's law here, then we can easily calculate the electric flux. And how we apply Gauss's law? What Gauss's law tells? It tells that flux enclosed by closed surface, flux enclosed by closed surface is equal to charge enclosed by the closed surface. Yani ki flux passing through closed surface is equal to charge enclosed by epsilon naught. So in this question, just try seeing how many charges will be inside this closed surface. So if you compare, if you see this thing, this is in XY plane. So this is same as this. Done. So in this portion, how many charges are present? So if you look at carefully, half portion of disk will be there. Half portion of the disk will be there. So overall on disk, how many charges are there? 6 coulomb charge is there. So in half portion, how much charges will be there? In half portion, 3 coulomb charges will be there. So what things we are getting? Just keep on writing here. Because of disk, how much charge will be inside the surface? 3 coulomb. Now let's see, because of rod, how much charge will be inside the closed surface. So you can see here which length of rod is inside the closed surface. Rod is varying from where to where? A by 4 to 5A by 4. And you can see clearly this coordinate of this point is how much? Coordinate of this point is A by 2, right? Kyunki this was A by 2. So this is also, this was minus A by 2. This is A by 2. So rod, length of rod that is inside this surface is from A by 4 to A by 2. Done. That will be from A by 4 to A by 2, right? So how much length is there inside? So if I'm going to show you, this was the case now. So rod was from here to here actually, here to here. So this is A by 4, this is 5A by 4, and this coordinate of this point is how much? A by 2. So which portion of rod is inside the surface? That is your A by 2 minus A by 4. So A by 2 minus A by 4. It means how much you're going to get? A by 4. So A by 4 portion of the rod is inside the closed surface. Now on rod, how much charge was there? So on rod, 8 coulomb charge is placed. Okay? Uniformly, that is also uniformly distributed. So for whole length of the rod was A. So for A length of the rod, 8 coulomb of charge is there. So for A by 4 length, how much charges will be there? 8 coulomb by A into A by 4. That is your 2 coulomb. So because of rod, how much charges we are going to get? 2 coulomb. Now, this charge is inside the closed surface. That is minus 7 coulomb. So 1 point charge is also there. And that is how much? Minus 7 coulomb. So how much total charge is inside the closed surface? That is your minus 7 plus 2 plus 3. So how much it is? Total charge, if I am going to write. So total charge you will write as what? This is equal to 3 plus 2 minus 7. This much coulomb. So this is minus 2 coulomb. So what will be the flux? Flux is what? Q enclosed by epsilon naught. That is your minus 2 by epsilon naught. Okay. So this is minus 2 coulomb by epsilon. This is the answer we are going to get. So just see here how much easy is the question. You were required not to do much. Only thing required was to see how much charges is there inside the closed cell. Okay. Now let's go ahead with next question. This question is very important. It comes very often. Again, so many times questions have come from this concept. That is why I have included it here. So I am again giving you some 3.5 minutes of time. Read it carefully and try solving. Again, when I say try solving it, I don't want you to exactly come with the answer. If you're coming, it's very good. Even if not, it is still very good. But please try. The thing is, you should try. So read the question carefully. Do it now. Please patiently read the question. Don't escape questions. You don't know, that's not an issue. But if you're not trying, that's big issue. So please do it. It's very easy again. But the thing is now, before I discuss, you must be putting some thoughts into the question. Then only when I will explain, that will come useful for you. Otherwise, if you're not solving or trying it yourself and only listening to how I am solving it, it's not going to help you. Okay? So you must try from your hand. Do it now. Okay, so let's solve it now. So what the question is, if you have solved it, let me show you the answer. So the correct answer is C and D. Okay. So now let's read it first and then do it. There are two non-conducting spheres of radius R1 and R2. Done. That is shown here. And they're carrying uniform volume charge density plus rho and minus rho, respectively. So one is carrying plus rho and another one is carrying minus rho, density of charges. And they are placed in such a way that they overlap partially. That is shown in the diagram at all points in the overlapping region. So in the overlapping region, what will be the status of all these four statements? That is basically the question. So the first thing is electrostatic field is zero. Will it be correct or not? So let's first see like the most common mistake that anyone can do here is by applying Gauss law. If you are going to do, yes, Gauss's law will be true here as well, but its application we should do very much carefully. So if you're going to apply this blindly, like Q enclosed inside this overlapping region, in this region, if you're going to see the status of Q enclosed, that will be how much? Zero. Q, क्योंकि this portion of a sphere, because of this portion, it is having minus rho density of charge, and this portion of a sphere is having plus rho density of charge. And when they will overlap, total charge will become as what? Zero. So Q enclosed here is zero. So does that mean electric field will be zero? So if Q enclosed is zero, definitely flux is going to be zero. But what will be the status of your electric field? Electric field can't be zero. Because outside this region, outside this overlap region, there is a plus rho density of charge, and because of these charges, what will happen? What will happen? Electric field will be present in this region. Done. So if charges are in the surround, just say you just take one closed surface like this, there is no charge inside, but there is a charge Q1 outside. Done. And this is non-conducting. No? It is written here, this is non-conducting. So if this is non-conducting and there is a Q1 charge outside, because of this Q1 charge, some electric field will be there inside. Because this Q1 electric field of this charge will be able to penetrate the surface because this is non-conducting, right? So here definitely flux is going to be zero, but electric field is not going to be zero. So first statement is what? It is false. Electrostatic potential is constant. Again, electrostatic potential आपका constant कब होता है? When electrostatic potential used to be constant, dV equal to minus E dot dl. So if E is zero, dV will be constant. So if first statement is wrong, second statement will also be what? It will also be wrong. Done. So first statement applies, second one. Now come to the third statement. Electrostatic field is constant in magnitude. So now we need to calculate the electric field. So how we are going to do that? So that we can do very easily here. Suppose I am drawing again the diagram. So this is the center of first sphere and this is the center of second sphere. Now let's take any point P inside the overlap region. Okay, any point P, let's take. Suppose this is the point P. At this point, I want to calculate the electric field. So what I'm going to do, I will see what will be the value and direction of electric field because of first sphere. So this will be in this direction because electric charges are positive inside it. And what will be the magnitude? Let's call it E1. So value of E1 is going to be what? Rho R1. Suppose this is R1. So rho R1 by 3 epsilon naught. We have already studied magnetic field inside a solid sphere, inside point of solid sphere, if charge is uniformly distributed and if it is non-conductive. So that formula used to be rho R by 3 epsilon. Done. What will be the magnetic field at point P because of second sphere? So direction will be like this. Direction will be like this because it has negative charge. So E2 is going to be how much? Rho R2. Now R2 direction will be what? P, position vector of point P with respect to C2. That is your this line. That is your this line, and this is R2. But electric field is in direction opposite to R2. Done. So electric field direction can be written as minus rho R2 divided by 3 epsilon naught. ठीक है. So electric field direction is in minus R2 direction, right? So what we are going to get, E1 plus E2. E1 plus E2 will be equal to what? Rho by 3 epsilon naught R1 minus R2. So this is R1 minus R2. This is R1, this is minus R2. So R1 minus R2 will be equal to what? Let me segregate it, otherwise. So E1 plus E2 will be equal to, E1 plus E2 will be equal to this, and R1 minus R2 will be equal to what? This is R1, this is minus R2. So R1 minus R2 is going to be equal to C1, C2. So what electric field magnitude we are going to get? Rho by 3 epsilon naught C1, C2. So here rho by 3 epsilon naught is constant. C1, C2 is also a constant. That is the distance between two centers, and that will remain constant. Done. So C1, C2 here is also a constant. So total electric field at any point, if you're going to take, I have taken any random point P. So if you're going to move this point P inside the space of overlapped region, you will at all time you will be getting net electric field as rho by 3 epsilon naught C1, C2. So definitely electric field is constant in magnitude. Now the electric field has same direction. Yes. Its direction will always be in the sense of C1, C2. So D is also correct. Done. So that we needed to calculate here. I hope it is clear. If you have any doubt, you can ask. Okay. Now let's look at this question. Again, for this question, I'm giving you 3.5 minutes. Done. Read the question carefully and try solving. Please read the question carefully, try solving it. And in case you're having any conceptual or any kind of doubt or any problem, let me know. Done. So I hope you all must have tried it. And okay, so correct answer, let me show you. So the correct answer will be A if you have got, or if you were just close to getting that. Okay, done. So let's now understand how to solve this question. So what the question is, first let's read it carefully. So the question is a uniformly charged thin spherical cell of radius r carries uniform surface charge density of sigma per unit area. So charge density on it is how much? Sigma per unit area. That is surface charge density. It is made of two hemispherical cells held together by pressing them with force F. Done. F is proportional to. So the question is that there are two hemispherical cells. One is like this. It has plus sigma charge density. And there is another hemispherical cell. Again, it has also plus sigma charge density. Done. And if you want to keep them together, we needed to apply force like this, like this. So it is asking what will be the value of this force F. Done. So for solving this question, we need to actually understand the concept. Like we have studied that if there is an electric field in the region, if there is an electric field in the region, then energy stored per unit volume in the electric field has some value, right? And that energy stored per unit volume, is how much? Half epsilon naught E square. Done. Half epsilon naught E square. And if you're going to see it very carefully, like there is also one more observation that if in electric field some charge containing surface is kept or some charge particle is kept, then it also receives some pressure. Done. And that pressure value is also the same as this half epsilon naught E square. Okay, same as energy stored per unit volume. Done. So like if you're going to see here, energy can be written as, if you want to see how these are getting equal dimensionally, I can show you. So energy is what? Force into displacement, and this is volume. So this can be written as displacement into area. So displacement will get cancelled, and force per unit area, that is your pressure. So what I want to tell you is that if any charge particle is kept in a electric field, it will experience a electrostatic pressure, and that pressure value is equal to half epsilon naught E square. So here also what is going to happen, like these two hemispheres were, suppose they were far away from each other. So one hemispherical cell is in electric field of another hemisphere. Done. And that electric field will exert pressure on it. Done. And if it is exerting pressure, it will exert force on it, right? So if force is acting on it, then we need to see that in what sense that electric field will apply the force. So let's see. Let's see here in the diagram only. So I'm going to draw it. Suppose I'm taking a small element here. So we have studied already that if there is a charge conducting charge surfaces or any charge surface is there, then just in front of it, what will happen? There will be an electric field, and its value will be how much? Sigma by epsilon naught. That we have studied, like if there is a conducting surface and it has charge density sigma, surface charge density, then just in front of the surface, electric field value used to be how much? Sigma by epsilon naught. And since this charge is positive, electric field will be in this sense. Done. So electric field is going to be in this sense. Now, what is the significance of this actually? What is going to happen? So let this angle be theta. So if this angle is theta, what is happening here? I have taken this small element on this hemispherical cell, and I'm trying to see what amount of force will act on this and in what sense. Done. So electric field is in outward direction. Charge is positive here. So force will definitely act in the outward sense. Done. Let's say this force value is dF. Now this force will have two components. One will be in this direction, that is your df sine theta, and one will be in this sense, that is your what? df cos theta. So two forces, this force df can be broken into two components, df sine theta and df cos theta. If I'm going to take another element here, then also here force will act in this sense, df force will act in this sense, and suppose this angle is theta as well. So again, this force can be broken into two parts, df sine theta and df cos theta. So here you can see that df cos theta component will get cancelled if I'm going to take two symmetrical elements here, and df sine theta wala component will get added. So total force acting in the outward sense. Force is acting because of electric field, force on the hemispherical cell is acting in outward sense. इसीलिए if we want to hold them together, we need to apply force in inward direction, because of electric field, force is acting in outward sense, so external force must be inward to keep them together, right? So that is why here the force shown indicated is acting towards the center, inward. Done. Now let's see, the total force will be what? That will be your df sine theta. Then it will be this. Now this df can be written as what? Here, if pressure acting is P, and if its area is, if this a small area is ds, then df can be written as what? Like if in term of pressure you are going to write the force, so we already know that pressure can be written as what? Pressure is force per unit area, and this area is what? This area is perpendicular to the force. So here you can see, let me draw the another diagram, actually it's going confusing now. So I have taken here, let's make it more clear. Okay, so यहाँ पे देखो, I have taken an element, done, and on this element df force is acting like this, done, and its area I have taken as this small element area I have taken as ds, so its area vector will also be what? In this direction. So area vector direction and force directions are like what? In same sense. So here pressure can be written as what? df by ds. Done. Clear here? So here df can be written as what? pds. Done. And what pressure can be written as? Pressure can be written as, I have already given you the formula. Pressure value will be same as half epsilon naught E square. And what will be the value of E here? Because here this surface is carrying a charge sigma, and in front of a conducting surface, electric field used to be sigma by epsilon naught. If charge density is sigma, then electric field value here will be how much? Sigma by epsilon naught. So now let's put the value. So let's first see df value. So P will be how much? Half epsilon naught E square is how much? Sigma square by epsilon naught ka square into ds. So how much we are going to get? Sigma square by 2 epsilon naught ds. So let's put this value here. So df value is how much? Sigma square by 2 epsilon naught ds sine theta integration. Okay. So now this is constant. Sigma square by 2 epsilon naught is constant. Let's take it outside. Sigma square by 2 epsilon naught. And inside will remain what? ds sine theta. Now what will be the value of integration of ds sine theta? Now this is the question. So if you're going to see carefully, here ds sine theta will be what? This is an area, and it will have two projections. One projection will be like this. Done. One projection will be like this. Just like force, it will have two components, like done. One will be along this line and another will be along this line. Done. So df sine theta will be along this line. Done. So component of ds along this line means this value. Done. Are you getting me? In this sense, I'm saying that ds sine theta is in this direction. This direction means what? This is ds. So this area will have two components. One will be this and another will be this. Done. So this area means this projection. Done. So if we are going to add all the components of ds along this line, so what we are going to get? We are going to get this much of area, and this area is equal to how much? Pi r square. So ds sine theta will be equal to how much? Pi r square. Done. So what answer we are going to get? We are going to get answer as, just write here, this is your sigma by 2 epsilon naught into pi r square. This is your total force acting. Sigma by 2 epsilon naught into pi r square. Done. So now see, F is proportional to what? F is proportional to sigma. F is proportional to r square. Done hai? Clear hai sabko? So this was the concept actually. I wanted to give it because I wanted to let you know what kind of like if something is kept in an electric field, then on this electric pressure will act, and that pressure value will be equal to half epsilon naught E square. So from that pressure, we can calculate the force if geometry is given. Again, we need to handle the geometry very much wisely. Okay? So that wise dealing of geometry is very much important. Only thing, I just want to recap this concept. Only thing important was कि pressure ka value will be what? So that will be half epsilon naught E square. In this question, electric field was sigma by epsilon naught. Done. So if we are going to put the value of electric field, we are going to get the pressure. Now we needed to calculate the force. So from pressure, we can calculate force. How? Pressure is force per unit area, where force is perpendicular to the surface. Yani ki force is along the area vector. Done. So here P equal to df by ds, df is P ds. So that we have written here. Done. And total force acting on the surface was how much? df sine theta. And ds sine theta became equal to how much? Pi r square. That was tricky. Done. So that is all. Now what we are going to read is, this is very interesting. Again, questions from capacitor will be damn easy. I'm telling you. Just I need to discuss one concept that will come very often in ahead, questions ahead. That is why I have decided to discuss that. That will take hardly 5 minutes. So let's see here. Suppose there is a battery. Done. And what I'm doing, I'm charging a capacitor through it. And its capacitance, suppose it is C1. Done. Now what I have done is, I have taken a switch and I have taken another capacitor, and that is here, C2. Yahan pe bhi there is a switch actually. Initially this switch is what? This is closed. And this potential is V1. So what will happen initially? By looking at it, you can say very easily that battery is connected to the C1. So C1 will get charged. Done. So if capacitor is getting charged by potential V, what charge it will have in the steady state? In a steady state, it will have charge C1V. Done. So this is going to get charge C1V. Done. Now this is done. Now what I'm going to do now is, I'm going to disconnect this one, and okay, let me draw it again. Just give me 1 second. So what I'm going to do, I'm going to open this circuit and close this circuit. Now what will happen? This is the question. So this C2 is now not connected to any battery, that is disconnected already from the circuit, but it is connected to another capacitor which is charged. So it was having a positive charge and it was having a negative, because it was connected earlier to the positive potential of the battery. It had charge C1V. And this capacitor plate has no charge, its potential is zero. It has no charge, its potential is zero. So what will happen? Charge will flow from here to here, from high potential to low potential. Done. And from here to here, it means it was having initially zero charge. It was also having zero charge. So high potential to low potential charge is flowing. So positive charge is going to come here. And this was having low potential, negative charge. This is zero. Positive potential, zero potential means positive. So it is high potential, it is low potential. Charge will flow from here to here. It means it is going to become negative. It is losing charge. and it is gaining some positive, it will become less negative. Done. So in short, what is going to happen? Let's not complicate it. In short, what will happen? Charge will flow from C1 to C2 until what time? Until both capacitors potential will become equal. So in a steady state, what is going to happen? Both the capacitor will have charge in such a way that their potential will become what? Their potential will become equal. And if two capacitors have potential equal, then I can say that these two capacitors are in what? They are in parallel. So here C1 and C2 are in parallel. So if question is like, what will be the final charge distribution on C1 and C2? How we are going to do that? So initially, at the point just when this connection was made, what was the charge on the system? This was the system, right? So what was charge on the system? C1V. Done. So initial charge of the system was how much? C1V. Final charge will be, sorry, इसको V dash ले to avoid the confusion. Okay. So final charge will be how much? C1 V dash plus C2 V dash. So final charge you write. Final charge will be how much? C1 plus C2 V dash. Done. And since charge is not going anywhere outside, it is traveling from C1 to C2 only. Done. So total charge will remain conserved initially and finally. So here you can write C1V equal to C1 plus C2 V dash. Done. So from here we can calculate V dash. We can see what is the final charge on C1 and C2. We can also see what was the initial energy of the system and final energy of the system. How much energy is getting lost. All these calculations we can do now very easily. So now let's jump on to the question. So this is a very easy question actually. Do it for now. Read the question carefully. I want you to read it very carefully. Take some 2.5 minutes of time. It won't take more than that if you know the concept. So read the question carefully and try solving it. Do it fast. Take your time. Be cool and calm. You can ask me doubt if you're having. I'm here only. Okay. But do it. you're getting the answer, you can let me know through chat section as well. It will be very good to read it. I hope it is done. Now, let's read the question first. So, in the circuit shown in the figure, there are two parallel plate capacitors. Each of capacitance how much? C. So, C1, C2 are having the same capacitance and its value is how much? C. The switch S1 is pressed first. So, first what we are doing, we are pressing the switch S1. Now, if we are pressing the switch S1, what will happen? Something C1 will get charged by potential 2V0, right? Now, after that, what is happening? And then it is getting released. Then, after C1 is getting fully charged, S1 switch is getting released. Switch S2 is then pressed to charge the capacitors C2. And after that, what is happening? We are closing the switch S2 and opening the switch S1. Then C2 is getting charged by C1. After some time, S2 is released. Again, after some time, we are also releasing S2 and then S3 is pressed. After some time, what will happen? When S3 is pressed. That's the question. So what will happen? Let's move ahead sequence 5. So what will happen? If we are closing switch S1, C1 is going to get charged by potential 2V0, right? So it will have how much amount of charge? Q equal to what? Q equal to Q equal to CV. That's the formula. So here potential is 2V0 and its capacitance is C1. So charge that C1 is going to get is how much? C1 into 2V0. Also, let's see which will get positive charge and which will get negative charge. So this plate is connected to the positive terminal, so positive charge. This plate is connected to the negative terminal, so negative charge. Now these things we are getting done. Okay, so it had charge C1 2V0. Now what is happening? We are disconnecting C1 from the battery. So this is getting disconnected and S2 is getting closed. Now what will happen? Now we are going to get a closed circuit like this, where C1 and C2 are connected with each other. C2 is not charged and C1 is fully charged. So what will happen here? Here C1 will charge C2 until both will have the same potential. Just now I have discussed. So same potential means these two capacitors will get in parallel, right? So finally what is going to happen after यहाँ पे S1 closed हुआ था. So S1 closed, then we are going to get charge on C1. After S2 is closed, what is going to happen? What we are going to see? We are going to see that C1 and C2 will become in parallel and they will have same potential. So in parallel means C1 plus C2. Suppose final potential is V dash and that will be equal to how much? C1 V. Because initial charge was there only on C1 and that was C1 V का value क्या था? 2V0. Then this much. Finally, charge will be on both plates such that both will have same potential. Yani ki they are in parallel. So C equivalent can be written as C1 plus C2. And final voltage, suppose it's V dash. So V dash can be written as C1 plus, charge can be written as C1 plus C2 into V dash. And initial charge will be equal to final charge. Just now I have discussed. Done. So here V dash can be written as what? C1, C2, V0. Let me put the values. C1 plus C2 will be equal to 2C. So V dash is going to be equal to what? V dash is going to be equal to V naught. So charge on C1 will be C1 V naught and charge on C2 will be C2 V naught. So finally potential that it is getting because of S2 getting pressed is V naught V naught. Done. And again it was having a positive potential, so it will have positive charge and it will have negative charge, like that. Now what is happening? Now we are again releasing S2 and closing S3. So if we are going to close S3, what will happen? This capacitor C2 is connected to a battery. Done. And negative terminal of the battery is connected to positive plate of the capacitor initially. Done. And negative plate of the capacitor is connected to positive terminal of the battery. So if you're going to see the final diagram is looking like this was the positive plate, this was negative plate, and this is going to be connected by negative terminal and this by positive terminal. Done. So finally what will happen? Initially this is the case. Finally this battery is going to do work in such a way that it will maintain the potential of this plate at negative, and this will maintain the potential of this plate at positive, and potential difference between these two will be V naught. Initially also it was V naught only. Initially also it was V naught. But polarity was what? This was positive, this was negative. After getting connected with the battery, polarity will get reversed because battery will maintain potential as the same as it is having. Done. So it is having potential V naught. It will also have potential V naught, but initially also it was having potential V naught. Only difference is of polarity. So what battery is going to do? Battery is going to transfer it some charges. Done. It is going to transfer it charges in such a way that first this positive charge will get nullified and then it will transfer it some negative charge. Value being CV naught. So finally what the diagram is going to be? Diagram will look like this. This will be your minus, this will be your plus, and this is V naught. Finally, also charge will be CV naught, but the polarity of plates has reversed. So how much charge it will transfer? It needs to transfer minus 2 CV naught charge. And then only here the charge will become minus CV naught. And from here charge will be how much? Plus 2 CV naught it will transfer here. Then finally charge will become plus CV naught. Done. So this is going to happen. Now let's match the column. Let's see which option is going to be correct. Charge on the upper plate of C1 is 2 CV naught. Finally, charge on the upper plate of C1 2 CV naught hoga? No, it's not going to happen because when S1 was closed, then C1 upper plate of C1 was having charge C1 2V naught. Done. But after S2 got pressed, what happened? It transferred some charge to C2. And since C1 and C2 were equal charge were transferred. Charge got half between these two. So finally, it was having potential V naught, C1 V naught. So finally, C1 upper plate of C1 capacitor had charge how much? C1 V naught. So this is what? Wrong. Now charge on the upper plate of C1 is CV naught. Yes, finally it is what? CV naught. You can see here, finally it was happening. Now charge on the upper plate of C2 is 0. Charge on the upper plate of C2 finally 0 hoga. No, it can't happen. Why? Because upper plate of C2 is connected to the negative terminal of battery and it will maintain its charge at minus CV. So the charge on upper plate of C2 is finally minus CV. So the question was this much simple. Okay. Now let's move ahead. Done. So what is the question next? Next is this question. Again, this is a very easy question. You need to read it very carefully to solve it. So read the question carefully. Take 2.5 minutes of time or I'm giving you 3 minutes of time. Okay. So take 3 minutes of time and solve it. Done. So I hope you all must have done it. Done. Let's read the question now. There is a parallel plate capacitor has dielectric slab of dielectric constant K between its plate and cover 1/3 of the area. So this area is how much? A by 3 if whole area is A. So this will remaining area will be 2A by 3, right? Total capacitance of the capacitor is C. Then total capacitance of the capacitor is how much? C. While that of portion with dielectric in between is C1. Its capacitance is given as C1. When the capacitor is charged, the plate area covered by the dielectric gets charged Q1 and another one gets charged Q. The electric field in the dielectric is E1 and that in the other portion is E2. Choose the correct options. First thing is, let's see here, there was a single capacitor, right? Its area was A and its distance between plates, let it be D. Done. So what we did is, in some portion, we have kept some dielectric. Its dielectric constant is given, that is equal to, how much was that? Okay, that is K actually. So let's assume that is K. Done. So because of the placement of dielectric, what happened actually, it divided capacitor into two parts, two different capacitors, we can say, right? So the one capacitor is this and another capacitor is this. Done. So it has capacitance given as C1. Suppose its capacitance is given as C2. Suppose. So this is C1, this is C2. Now these two capacitors are in what? Are they in series or parallel? So if you see carefully, both the capacitor will be in parallel. Why? Because both are sharing the same plate actually. One is sharing 1/3 of that plate and another is sharing 2/3 of that plate. But same plate is getting shared by both the capacitor. Done. It means if this plate has potential V1 and if this plate has potential V2, then potential difference between these two plates will be how much? V1 minus V2. Done. So these two capacitors are in parallel. It means potential difference between these two different capacitors will be same, V1 minus V2. And if potential difference is same, electric field will also be remain same. क्योंकि यहाँ पे potential difference can be written as what? ED. So if dV is same, E will be what? dV by D. That is also same. And distance between capacitor plate is what? Same here. So electric field is going to remain the same. It means option 1 is going to be correct. Done. And this is going to be wrong. Now let's see how we can relate Q1, Q2. Done. And C1. Just see here, what was C? Total capacitance of the capacitor is C. Done. Now let's write the value of C1 and C2. Let's do that first. So C1 can be written as what? C1 can be written as epsilon naught A by 3D. Done. And C2 can be written as what? Epsilon naught into 2A by 3 into D. Done. So this is C1, C2. So C can be written as capacitance. These two are in parallel. So in parallel, how we write capacitor? Like how we will add in parallel? In parallel, we can simply add like C1 plus C2. So if you're going to do that, what you're going to get? Epsilon naught A by D. Let's take that as common. And sorry, C1 was having dielectric of K1. So here K1 we need to write. Epsilon naught A by 3D को मैंने common लिया है. What we can write now? K1 plus, how much will be this? K1 plus 2. Done. So this is K1 plus 2. C is this. Now C1, ratio of C by C1 will be equal to what? You just calculate the ratio of C by C1. So C is how much? Epsilon naught A by 3D K1 plus 2. And C is how much? Sorry, C is this. C1 is how much? Epsilon naught A by 3D. Done. So C by C1 we have to do, right? Epsilon naught A by 3D. And this is your K plus 2. Divided by how much? Epsilon naught A by 3D K. Done. So epsilon naught A by 3D will get cancelled. And what we are going to get? K plus 2 by K. So D is correct. Now let's check Q1 by Q2. So value of Q1 we can write as what? Value of Q1 we can write as what? This is the answer. Q1 can be written as C1V and Q2 can be written as what? C2V. So we were asked what? Q1 by Q2. So let's write Q1 by Q2 will be equal to what? C1 by C2. How much was C1? Epsilon naught A by 3D K1 divided by how much was C2? That was 2 epsilon naught A by 3D. Done. This was the value. So if we are going to cut it, what we are going to get? We are going to get K1 by 2. So what is given here? 3 by K. That's not the correct. That is wrong. Done. So this question was very easy. Now let's move ahead with this question. Do everyone please try it. I'm just giving for this 2 minutes. Do it fast. Done. So let me do it now. There is a simple pendulum of length L, and this is placed between the plates of parallel plate capacitor having electric field E as shown in the figure. Done. If Bob has a mass M and charge Q, time period of the pendulum is. So first of all, what used to be the formula for time period of pendulum? That used to be 2 pi root under L by G effective. Now, the main task is to find G effective. And how we calculate G effective? For calculating G effective, just see the equilibrium point of Bob. So here, suppose initially Bob was like this. So there was no capacitor placed in between. So what will happen in that case? In that case, tension force will act in the upward direction and mg will act in the downward direction. Equilibrium position will be this only. Tension will be equal to mg. So there, the G effective is how much? M. G effective is how much? Like at equilibrium point, you just equate tension to mg. So G effective is G only. Done. Now, the moment we are going to put two plates of capacitor in between, what will happen? Electric field will come into action. And that electric field direction, sorry, this was negative charge, this is negative. So that electric field direction is in this sense, and it is having positive charge. So electric force will act in the direction of electric field, that is QE. Now what is going to happen? Equilibrium position will change. And new equilibrium, since electric force is acting in this direction, it will try to shift the ball in this sense. So somewhere here, it will come. And that will become its new equilibrium position. So its new equilibrium position is this. Now at new equilibrium position, just see what is happening. Tension force is acting in this now. It is looking like this now. Let me draw it here. So tension force is here. Mg is acting in this sense and QE is acting in this sense. So what is G effective here? So net force acting will be equal to how much? Tension will be equal to how much? M G ka square plus QE ka square. Done. So G effective will be how much? Just equate tension to something. Whatever that something you are getting, sorry, this will be root under net force. Whatever that something you are getting, that is a force, divide that by mass. So that will give you what? G effective. So here G effective value will be how much? Root under mg square plus QE square by m. So it is going to be G root under G square plus QE by m ka square. So the correct answer will be how much? 8. 2 pi L by root under G effective. Done. So how to calculate G effective in case of simple pendulum? Simply see tension is equal to which force. Whatever force you are getting, divide that by M. That will give you what? G effective. Okay. Now let's do this question. Everyone please solve it. Again, same as the second one, the one that we have already done. So again, I'm going to give you only 2 minutes because in 2 minutes it will get done. Do it now. Read the question carefully and solve it. This is the simplest question actually that you can get in the exam. And from capacitor portion, you will be always getting easy questions. Just you need to do a little bit of calculation, a little bit of concept you need to have in your head. That will be enough. Like if you have studied in G mains all the concept of capacitor, that's almost enough. Only thing is calculation might get up here. Okay, so let's see the question now. There is a parallel plate capacitor having plate area S and plate separation D, right? Has capacitance C1 in air, and its capacitance in air is given as how much? It is given as C1. Done. So let's first write the value of C1. So C1 will be equal to epsilon naught area, that is S by T. Done. So this is C1. when two dielectrics of different relative permittivities, 2 and 4, are introduced between the two plates as shown in the diagram. So first you do what now? You just draw the parallel plate capacitor. And here what is happening? Here, this dielectric is kept up to distance d by 2. So separation is something like this. Let me do such separation. Okay. So this distance is how much? This is your d by 2. And here dielectric kept is epsilon 2. Its value is 4. And here it is epsilon 1. Its value is 2. Here also it is epsilon 1. And its value is 2. Right. So capacitor is getting divided like this because of dielectric. Now, what will be the C equivalent of this capacitor? It is asking about C1 and C2. So what is given here? C1 was the capacitance of capacitor without dielectric, and C2 is what? C2 is the capacitance of capacitor when dielectrics are added here in this manner. Done. So final capacitance we need to calculate first to calculate the ratio. So let's see what is happening here. So capacitor has been divided into how many regions? 3 regions. Epsilon 1, this one, this one, this one, and this one. So these two capacitors, epsilon 1 and epsilon 2 wala portion, in this portion you can see, these two capacitors are in what? Are they in series or parallel? Let me get it done. Okay. So first is this one. This is epsilon 1, this is epsilon 2, this is epsilon. So let me say this is 1, this is 2, and this is 3. So capacitor 1 and 2 are in what? Series or parallel? They are in series. Done. Because they are not sharing the same plate. This one, 2 plates of the first capacitor, and 2 plates of the second capacitor are this one and this one. Then their potential difference is not going to be same. Suppose its potential is V1, its potential is V0, and its potential is V0. So for first, potential difference is V1 minus V2. For second, potential difference is V0 minus V2, which is not equal. Done. So these two capacitors are in series. Now, what will be the equivalent on 1 and 2? So C12, that will be 1 by C12 equal to 1 by C1 plus 1 by C2, because if capacitors are in series, we add them like parallel. So what will be the value of C1 actually here? So first we need to write the value of C1. So C1 will be how much? C1 will be epsilon naught area. How much was the area? So this was taking half of the area. So that is also the half. So if this is S by 2, this is also S by 2, and this is also S by 2. So epsilon naught S by 2 into distance. This was D by 2. So this is D by 2. So this is going to be epsilon naught S by 2. Done. And it was having a dielectric epsilon 1. And its value was how much? Epsilon 1 value was 2. So write here 2. So this will become epsilon naught S by D into 2. So this is equal to 2C. Done. Because C was equal to how much? Epsilon naught S by D. Now let's calculate the C2. So C2 value we are going to get as what? C2 will be equal to how much? Again, that is equal to epsilon naught S by 2 into D by 2 into 4. Done. So this is equal to 4C. Clear hai? So this is 1 by 2C plus 1 by 4C. And if you're going to calculate it, you are going to get how much? If you multiply it with 2, divide it by 2. So this will become how much? 3 by 4C. So C12 value will be how much? How much value of C12 we are going to get? So C12 will be how much? 4C by 3. Now let's see the value of C3. C3 can be written as what? Epsilon naught S by 2 into D into dielectric. Epsilon 1 value is 2. So this is equal to C. So C3 is equal to C. Now this C12, so I have called this as C12 and this is your C3. So this C12 and C3 are in parallel because its potential is V1, its potential is V2. Potential difference between C12 and C3, both are same, V1 minus V2. So these two are in parallel. So finally, What will be the value of C2? C2 will be C3 plus C1 2. And that is equal to how much? C3 is C, C1 2 is 4C by 3. So that is your 7C by 3. So C2 is 7C by 3. Done. So C1 was how much? C1 was equal to epsilon naught S by D. And this one I have called as C. This one I have called as C, and C2, that is in the question, capacitance of capacitor after putting dielectric, that is equal to how much? We have just now got that 4C by 7C by 3. So what will be the value of C2 by C1? So C2 by C1 will be nothing but 7 by 3. C2 by C1. Done. So this will be your correct answer. Now do it fast. Take your some 3 minutes of time. In that period, you will be able to do it. So you have to deal with time constant. Time constant of RC circuit is how much? That is equal to R into C. So simply you have to calculate the value of R into C. R is already given. Capacitance you need to calculate here and then multiply it by R. Do it now. Take 3 minutes of your time and done. So let's do it now. So the question is parallel plate capacitor C with plates of unit area. So its area value is how much? It is given as 1. And separation D filled with a liquid of dielectric constant, K ka value is 2. The level of liquid is D by 3 initially. So this was D by 3 initially. Suppose the liquid level decreases at a constant speed. So D by 3 is going to increase with constant speed. Then time constant as a function of time t is done. So let's draw the capacitor here. So this is the capacitor. Initially, this separation was how much? D by 3. Now it is decreasing with a speed v. Yani ki in time t, how much length will decrease? How much length will decrease? Vt. Done. So time t, Vt length is decreasing. It means at any time t, this will become equal to, initially it was d by 3. So it will become d by 3 minus Vt. And how much it will get if this is decreasing, if this is coming down, water is coming down, it means this space will increase. So that initially was how much? 2d by 3. That length initially was 2d by 3. And it is increasing with the same rate at which d by 3 is decreasing, right? So you will be writing here as what? 2d by 3 plus vt. So this is the separation between these two plates. So we are getting two capacitors here, one with dielectric and another without dielectric. So one is this, another is this. And these two dielectrics are in what? Series. Again, they are not in parallel. Same reason. If this is V1, this is V2, and this is V3, then potential difference between first place is V1 minus V2, and second capacitor is V2 minus V3, not equal. So they are not in parallel, they are in series here. Done. And if I am going to call the capacitance of first capacitor as C1 and capacitance of second capacitor as C2, then C1 can be written as what? C1 can be written as epsilon naught A. Area is 1 divided by distance, that is 2d by 3 plus Vt. Done. And what C2 can be written as? C2 can be written as epsilon naught, area is 1 by distance, that is d by 3 minus v. Now what will be the C equivalent? 1 by C equivalent will be equal to 1 by C1 plus 1 by C2. So you need to do the calculation here. What will be time constant? R into C equivalent. So in that way, you will be getting the answer. And the correct answer will be A. Okay? So now you can, that calculation you can do very easily. Now let us do this question actually. So I'm just giving you 2 minutes of time to it. And let me know. Done. So question is very easy actually. You all must have done it. Correct answer will be your D. So a 2 microfarad capacitor is charged as shown in the figure. Done. The percentage of its stored energy dissipated after the switch S is turned to 2. Done. So suppose its potential is V. So initially, this 2 microfarad capacitor will get charged with potential V. And energy initially, if I write initial energy, that will be equal to how much? Energy will be only on 2, stored only on 2 microfarad capacitor. So it will be equal to half CV square. C is how much? 2. Half 2 into V square, that is V is done. So this is our initial energy. Now finally what is going to happen? That we need to see here. So finally I'm getting this switch here and this is getting disconnected. So this 2 microfarad capacitor is now charging 8 microfarad capacitor. Done. And it will charge it, and a situation will come when both will have the same potential, and then no net flow of charge will happen, right? So finally, it will have some, suppose it has final potential at V dash and it has final potential at V dash. Both will have same potential, right? So finally, charge on 2 microfarad will be equal to how much? 2 V dash. Charge on 8 microfarad will be how much? 8 V dash. And this will be equal to initial charge on the 2 microfarad. Already we have discussed it so many times. So 2 into V. So how much value 10 V dash is this? This is 2V. So V dash is how much? V by 5. So final potential is V by 5. So energy stored on these two capacitors finally will be how much? So let's write the final energy. Final energy will be how much? Finally, these two capacitors are in parallel. So C equivalent can be written as 10 and its potential is V dash. So half C, that is 10 V square by 25. So this is going to be how much? This is going to be V square by 5. So initial energy is V square, final energy is V square by 5. How change of energy is happening here, that we need to write now. So change in energy is how much? V square minus V square by 5. That is your 4V square by 5. So what is the percentage change? Delta E by initial energy, and into 100 percentage change. So that is 4V square by 5 divided by V square into 100. And that is going to be what? 80%. So 80% of energy is getting dissipated, right? So large chunk of energy actually done. So this is all. In the next class, I will be dealing with some some two questions of capacitor more. And after that, we will be dealing with questions from current electricity. Through questions only, we will be learning concepts as well. That will be more useful because in G-Means already we have done the revision. We have gone through formulas and all. So higher concepts, we will be learning. Those small concepts, we will be learning through questions only. Done. So take care. Bye-bye. And keep doing questions, keep reading, have patience, and invest yourself properly. Stay healthy and enjoy, I mean, reading, and also enjoy your weekend time.